What's the agROBOfood project?
Many stakeholders in agROBOfood are not aware of the opportunities that robotics can offer to their companies and businesses. Perhaps they have never even thought about it. And that is where agROBOfood comes into play. It's an EU-funded innovation action building an European ecosystem for the effective adoption of robotics technology in the agri-food sector. As such, agROBOfood is carried out with the help of 38 direct partners from across the EU. Being led by Wageningen University Research, agROBOfood is also counting with a funding of around 16 million euros from the EU budget.
What are the project objectives?
agROBOfood is dedicated to accelerate the digital transformation of the European agri-food sector through the adoption of robotic technologies. As such, the project consolidates, extends and strengthens the current ecosystem by establishing a sustainable network of digital innovation hubs. This in turn boosts the uptake of robotic solutions by the agri-food sector.
Can you tell us something about the agROBOfood instrument of open calls?
The heart of agROBOfood is formed by innovation experiments, which can be regarded as little sub-projects in agricultural robotics. These experiments are supported and monitored by digital innovation hubs. And some innovation experiments were on board straight from the beginning of the project, while others joined later on, like our project or our mini project H3O-SpotOn. They were selected among a large number of competing proposals as the winners of the agROBOfood open calls. And in this respect, in fact, 8 million euros of the total budget, roughly half of the budget, have been adjudicated through this instrument, the open calls. And Pulverizadores Fede, together with its partners agROBOT, Pavlak from Poland, Krampak from Slovenia and Chem2 from Tunisia, is very proud to have succeeded with H3O-SpotOn in this very fierce competition.
Can you describe the problem?
Our innovation experiment H3O-SpotOn carries the full title Healthy Crop, Healthy Environment and Healthy Farmers' Finances through Optimized Spot Spraying Robotics. Like many of Fede's research projects, also H3O-SpotOn pursues the overall goal of lowering the amount of pesticides used in fruit, olive and wine production, while keeping pests at bay and assuring farmers a high quality yield. As such, H3O-SpotOn is built on Fede's well-established H3O technology that revolutionized the specialty crop sprayer world with cloud-connected sprayers already in 2016.
Using H3O, work orders can be generated in Fede's specialty crops platform. Then they can be downloaded to the sprayers and easily be executed in the field, with spraying equipment automatically adjusted to crop dimensions. Moreover, full traceability is provided and back-office analysis of the spraying results gives farm managers the assurance that their crops are safe.
What is the proposed solution and its practical implementation? And what are the challenges for the market introduction?
With H3O-SpotOn, we go a significant step further, allowing to see the crop dimensions and then adjusting the sprayer on the fly. Spraying precisely on spot reduces ground losses and spray drift, which in turn is good for the environment, but also good for farmers' finances, albeit as prices for phytosanitary products are currently skyrocketing.
To prove our point in different crops and under different climatic conditions, H3O-SpotOn ran trials in Pawlok's apple orchards in Poland, Krampak's vineyard in Slovenia, and in Chem2's citrus plantation in Tunisia. The H3O-SpotOn experiment received further support from the digital innovation hubs, like EST agROBOfood in Slovenia and from digital innovation hub Innovation City in Tunisia. They helped us a lot, for example, to overcome market entry barriers like legal requirements or language issues.
Turning to the agronomic results, adding spot spray technology to our already high-end H3O sprayer base was found to deliver additional phytosanitary product savings in the order of 10 to 20%. Comparing to standard sprayers that exist still on many farms, savings potential is even higher in the order of 40%, which is well in line with the EU's Green Deal Farm to Fork target of 50% hazardous pesticide reduction by 2030. Further, as spray water is saved as well, the frequency with which you have to go and refill the sprayers is significantly lowered, which reduces in turn the operation time you need for spraying as well as the gasoline consumed.
End user testimony, Krampak, Slovenia.
Na podlagi tega se pravi lahko privarčujemo na porabi fitofarmacevtskih sredstev, se pravi, če upoštevamo vsa ta priporočila in svoje znanje, lahko zmanjšamo količino porabe teh sredstev in na ta način varujemo tudi naše okolje.
What are the main conclusions of this project?
Concluding, it can be said that the agROBOfood project and its network of digital innovation hubs gave us the chance to bring spot spray technology to market maturity and to demonstrate savings in crops as diverse as apple, citrus and vine across Europe and Africa.
In addition, the support of the local digital innovation hubs in Slovenia and Tunisia is in this respect highly appreciated. They have the local people on the ground that can quickly and with technical skill resolve problems arising during the international rollout. Clearly, we would also like to thank the European Commission and its funding agencies that make hands-on innovation as demonstrated by H3O-SpotOn possible. And we would like to thank Jesus Pablo González from agROBOfood, the Catalan Robotic Digital Innovation Hub, for supporting and mentoring this innovation experiment right from the start.